MARUCA pod borer is an insect pest that affects cowpea plants, popularly known as beans, in Nigeria. It remains the major challenge to the crop's production in this part of the world. Data shows yield losses of up to 80% in severe cowpea infestations. This has resulted in low yields and little income for farmers, particularly in Nigeria's rural communities. Glad to have you join us on AGRIBIOTECH for today as we discuss biotechnology options of addressing the MARUCA pod borer menace in Nigeria. I am Lara Afolayan. Today on AGRIBIOTECH, we take a look at the MARUCA-resistant cowpea project. The African Agricultural Technology Foundation, which is the mastermind of this project in Nigeria, will be speaking to us as we also visit the Institute of Agricultural Research at the Ahmadu Bello University in Zaria, where the project's confined field trial has been carried out several times. But first, let's take a look at recent developments in agricultural biotechnology around the world. Ghana's National Biosafety Authority says genetically modified crops have a high potential of controlling the fall armyworm. The agency's Chief Executive Officer, Eric Amaning Okori, says fall armyworms could not affect all plants, which means that some plants have natural resistance. He adds that this meant maize and other crops which could not withstand the armyworm needed to be genetically modified. Chairperson of the Ugandan Parliamentary Committee on Science, Roberto Kafiru Sekitoleko, says the country's adaptation of biotechnology for agriculture would offer great economic gains. He says rural farmers in Uganda are looking for seeds that offer good yields, resistance to pests and diseases, as well as being drought tolerant, which genetically modified crops offer. The lawmaker feels the country's non-passage of the Biosafety Bill will put it at a disadvantage because neighboring Ethiopia and Kenya, who are about commercializing the GM cotton, will bring such products into Uganda in processed form. The European Academies of Science Advisory Council says EU policymakers need to implement a food systems approach that will address negative impacts of climate change on food systems and encourage healthy, environmentally sustainable diets. This is contained in its report on opportunities and challenges for research on food, nutrition and security in Europe. The body calls for a change in consumption patterns through the use of latest agricultural practices and technologies. Farmers in Nigeria have identified MARUCA insects as their biggest problem in cowpea cultivation. MARUCA's damage to cowpea plants results in a reduction in size and quality of harvest. And even though conventional insecticides can be used to control this pest, they are expensive, their availability to farmers is limited, and because farmers have little or no training on their usage, safety problems arise during application. MARUCA-resistant cowpea seeds have now been developed through public-private partnerships managed by the African Agricultural Technology Foundation, AATF. This particular cowpea variety has been modified through the Bacillus thuringiensis gene, also called the BT gene. The variety has now been identified as the preferred one for farmers in countries like Nigeria, where successful confined field trials on the MARUCA-resistant cowpea have been carried out. On InFocus today, we see how the AATF's MARUCA-resistant cowpea project is bringing solutions to the pod borer pest challenge in Nigeria's cowpea industry. Africa accounts for 65% of the world's cowpea production. The commodity is consumed by over 200 million Africans, and this explains why it is grown on over 12.5 million hectares of land in sub-Saharan Africa. Cowpea is considered the most important food grain legume in the dry savannas of tropical Africa. It is not only rich in quality protein, but is a good source of quality fodder for livestock and provides cash income for farmers as well. But the pod borer, scientifically known as the MARUCA vitrata, a major lepidopteran pest which inflicts severe damage to cowpea crops, remains a threat to yields in Nigeria.
MARUCA, number one, there's no cowpea variety that has a natural cultivar that can resist it. So some others, somehow you can manage to have some resistant varieties. But this MARUCA vitrata is really, let me use the word, a very stubborn pest and very hard for farmers to deal with.
Farmers could lose up to between 70 and 80% of yields when the MARUCA infestation is severe.
This is the damage caused by pod-soaking bugs. It bursts into the pod. And this one is likely even to escape the heavy infestation of those pod-soaking bugs, also causing a lot of damage to cowpea pod. And this one also reduced the yield in the farmer's field.
The Africa Agricultural Technology Foundation, ATF, has introduced a pod borer resistant cowpea project to boost cowpea production in Nigeria and other countries in sub-Saharan Africa.
So it's meant to increase the productivity of beans by addressing some of the constraints that farmers encounter in the field, specifically the constraint of insect pest attack, which ravages the field.
We have been able to find out the performance of this potentially new variety, which will be grown by farmers. It has a yield advantage of at least double-fold of what is expected with only 2 sprays of insecticide.
Confined field trials for testing the efficacy of the Bt gene in controlling MARUCA has been successfully conducted in Nigeria by the Institute of Agricultural Research at the Ahmadu Bello University in Zaria. AGRIBIOTECH visits the trial site to see how the crops are doing. First, we visit the glass house where the Bt gene, which confers resistance to the pod, is transferred to allow for improved cowpea varieties in this nursery. And then we move to the field trial site where the genetically modified crops from the glasshouse nursery are planted beside the conventional ones. The scientists here say the difference between the 2 crops become clearer and clearer as they begin to bud.
To my right is the conventional local varieties planted by farmers, which is photosensitive, meaning they don't flower until when the day length is short. So this is a disadvantage, particularly with the prevailing changes in our climate. But when you look at the transgenic line here, they were planted together with this the same day. This flowered, matured, and even has been harvested. So even with the early cessation we experienced this year, you can see this one has escaped the early cessation, and there is not going to be any way we are going to have crop failure here.
Local cowpea farmers are involved in this project. They say the experience here shows that the MARUCA pest can indeed be put at bay without having to spray so much chemicals. They add that these improved cowpea varieties could reduce planting cost, increase yields as well as income.
The number one we have been growing, we've been having a lot of problems along the line, which especially during spraying. We spray up to 7 to 8 times within the season. And then with the new one now that we have seen, it's of more benefit because we have to spray less than that time, and the earliness of the early variety, the new variety, counts a lot because between no time it's almost due, and then you have food for the family.
Akwai wani wake da aka bamu nan muka zo muka shuka, kuma mun hada shi da irin namu local da muke shukawa, kuma gashi a yanayin yadda muke mishi aiki baki daya gashi mun samu wani bambanci. Shi wannan da aka bamu muka shuka daban ya bambanta da wanda muke shukawa.
It is quite interesting to see that the genetically modified variety looks exactly like the organic ones.
Can you tell me the difference? Can you see the difference? Yes, no? No. Because morphologically, the genes has no effect, or this does not alter the morphology of the seed, the morphology of the plant also.
The field trials have been carried out successfully and the crops harvested, but there is no damage to the environment as claimed in some quarters. The land here is now to be used for future confined field trials.
If you look at this land, this is a confined field trial that was started this trial with for almost 9 years now. And look at the soil. Nothing has been changed with the soil. From that 2009 to date, we have been planting these transgenic materials and nothing changed with it, in terms of the soil quality.
Scientists involved in Nigeria's MARUCA-resistant cowpea project say it has been hugely satisfying.
The cost of producing cowpea, for example, will come down, and so cowpea will be afforded by many more people who are now finding it probably too expensive for them to consume. So, and also the farmers who grow it, they are going to make a lot of margins of close to 25% or about 25% of margin from the production.
They are positive it could help resource-poor farmers and enhance food and ecological security in Africa. The Port Bora or MARUCA-resistant cowpea project in Nigeria is coordinated by the African Agricultural Technology Foundation, AGRIBIOTECH, to promote technological innovations that optimize cowpea productivity and utilization in sub-Saharan Africa. The regional head, West Africa, of the AGRIBIOTECH, Dr. Isufu Kolo Abdurrahman, chats with us on this initiative. Talking about the AGRIBIOTECH's MARUCA-resistant cowpea project in Nigeria at the Ahmadu Bello University, what prompted this and how did it exactly start?
All the national research institutes like ABU, the international research institutes like IITA, which had mandate for cowpea, they look at the whole world collection of cowpea. We couldn't find any single variety that is resistant. So then the cowpea groups working on cowpea said, why don't we try to take this technology and develop a MARUCA-resistant cowpea for our farmers? So this is how the idea came, and AGRIBIOTECH took responsibility to coordinate the whole effort to develop this MARUCA-resistant cowpea.
Okay, so how many confined field trials have been done so far?
Only confined field trials have been so far, because there is, for any GM crop, initially you start with the confined field trials. You gather all the data on the biosafety of the crop. You submit this data to the biosafety management office in the country, authority in the country. When they look at all the data now with the experts, they are able to say this crop is safe, it does not present any harm to the environment, to human health, or to any soil, organism, anything. It is safe for human consumption. Then they will allow us to go to the farmers' trials. This is how it is done in the US, this is how it is done in Europe.
But I know that the idea of this project was to make the seeds available to farmers in 2017, and that was subject to approvals from regulatory agencies, identification of effective and stable MARUCA-resistant lines, and efficient transfer of the gene to traditional varieties through conventional breeding. So what is the situation at the moment?
Okay, most of the things you have said have been done. The gene has been transferred by doing normal, conventional genetic When we get the first line, which was modified using biotechnology, we cross it to the farmers' varieties, preferred varieties, to develop a new, to modify the farmer's variety. This technique in genetic language, breeding language, conventional, is back crossing. So that was done. And we have tested in different regions in Nigeria. We conducted our tests in Zaria, in Zamfara, and in Kano. We got confined environments. Outstanding performance.
Okay, now how are farmers expected to access these seeds, after all the conditions have been
farmers who have seen it, the cowpea, first of all, they love it. They keep on asking us about the cowpea.
But how would they get it?
But no, we'll go, how we get it, we'll get agreements, MOU with the seed companies. We want Nigerian private seed companies to take it and be in charge of commercializing the seeds.
Okay, so how sure are we that these seeds will work in our farming system here in Nigeria?
Oh, for sure. We give the seed to the farmers to try in our confined environments. And we invite a group of farmers to visit our trials. They get surprised. You may ask our communication specialist, I will tell you from truth. Farmers love it. Farmers who have seen it, hundreds of farmers have visited our trials. They love it. And we did ourselves a survey. More than 60% of farmers in northern Nigeria consider PBR, our MARUCA resistant cowpea, as the #1 select variety they like.
Okay, I know there are quite a number of concerns about the GM technology in this part of the world. So how safe is the MARUCA resistant cowpea for consumption?
It is as safe as any other cowpea in the market. This is the first GM BT cowpea in the world, what we are developing. This is the first one in the world.
Okay, so for Nigerians out there, watching you, this is the first of its kind. What is your word of assurance to them concerning this particular
because we
variety?
analyzed what I tell you. We took leaf samples. We had analyzed the plant sample, leaf, flowers, everything. We took all the samples and we analyzed them chemically and compare it with the normal cowpea. There is absolutely no much differences.
Okay, now what far-reaching implications does it have for the Nigerian economy, in the long run?
People think cowpea is a subsistence crop. This is the first mistake. Beans. People think it is only a subsistence crop. That's the first mistake. Cowpea is highly commercial crop. Very commercial crop. Most of the millionaires in northern Nigeria, and if you go to Niger, in southern Niger, because northern Nigeria is southern Niger, most of the millionaires you find started with selling cowpea. Nigeria imports 40% of its beans. 40% of the beans consumed in Nigeria are imported from Niger, Burkina, and Chad, even from Chad. People don't know Nigeria imports beans. So, and these represent billions of nairas. I don't say millions, I say billions of nairas in saving this cowpea will bring to Nigeria.
Okay, can the BT cowpea seed be replanted, and does it degrade the environment?
The cowpea seed can be replanted generation after generation for almost 1,000 years or 2,000 years or for 1 million years if you can save the seeds. And we produce it, we multiply the seeds.
And can the land be
reused? And we plant it every year, and the land is good. It has no detrimental effect on the land.
The land can be reused for planting?
For anything, any crop you want.
Thank you very much, sir, for joining me on the program. And that was Isufu Kolo Abdurrahman, the Regional Director, West Africa of the African Agricultural Technology Foundation, speaking on the BT cowpea in Nigeria. And you heard him right. The BT cowpea seed can be replanted and it does not degrade the environment. We'll take a quick break and the program will continue shortly. Stay with us. And next, we speak with Dr. Mohammed Lawan Umar, the trial manager of the BT cowpea project at the Institute of Agricultural Research of the Ahmadu Bello University in Zaria. Okay, now let's talk about the ongoing research, to combat this MARUCA challenge at the Institute at the moment.
So we've conducted several years of field testing, and we identified some promising lines that perform wonderfully, where they confer resistance to these insects. So when they see that one, we have selected some of them, and then we now look at the one that is adapted in the country, and we started making crosses. We started making crosses with our adapted materials, which is already commercialized. So we married the two, make a crossbreeding to insert the gene into our farmers' preferred variety in the country. And we have done so for so many generations. And after then, we took those material derivatives that we obtained from the crosses we made. We tested them also across different locations, because the work has been done in Zaria here. After then, we take it to Kano, which is in the Sudan savannah, as also to Bakura in Zamfara, which is also in Sudan's savannah, and also transition to Sahelian zone, where the rainfall is not as high as that of Zaria. That's what we did.
Okay, so what kind of variety is this BT variety?
Well, BT, when we say BT, means Bacillus thuringiensis. The BT means Bacillus thuringiensis, meaning that it's a name of a soil bacterium. It's a bacterium in the soil, so it's just the name. So when the gene was identified from that soil bacterium, we now take the names and give it the name, the BT gene. But the scientific name is called CRY1AB gene. CRY1AB gene. That is the BT gene, the gene isolated from the soil bacterium, which is conferred resistant to this MARUCA vitrata, the food-borne insect.
Okay, now what makes it different from the organic cowpea?
Yeah, the organic or the conventional cowpea or beans that we are growing in the country, it has no gene that is conferred resistant to this insect. That's the only difference. But if you look at morphologically, there's no difference. The conventional and the transgenic one.
Okay, what was the observation as regards pest infestation of the plant?
Yeah, the mechanism that the gene is working is that when the MARUCA is searching for food, so it will go, when it tests that this one, it may not find it may be palatable, so it will go to the one that is suitable. It doesn't carry the genes. So you see there's no damage. When we do the damage assessment, we realize that we can call it zero damage for the transgenic one, unlike the conventional one where it has a high damage to 70 to 80% were damaged by this insect. That is a severe infestation.
Okay, what exactly is in the transgenic plant that makes it repulsive to pests like the MARUCA?
The only things, our additional value was that of the gene, new gene that was inserted into it. That is the CRY1AB gene, is the only thing that is differentiated from the conventional one, and also make it to be more resistant to this insect. Because the other ones doesn't have such kind of gene. It is not, they are susceptible to this MARUCA, the other conventional cowpeas.
Okay, and with your interaction with these farmers, how receptive were they to this technology?
Yes, we also did what we call preference ranking for the farmers and perceptions, kind of studied with the farmers and also invited farmers at the end. Apart from the farmers that participated in the trial, which is farmer managed trial, we invited other farmers to come to see it for the first time and then to go through the field. And please go through the select which one do you like best and tell us the reason why you selected this one. So about 70% across the location, they selected our variety, the new entry. And the major reason they said, the major reason is protection against this insect, because it was only 2 spray, because they used to spray more than 5 times. And this one sprayed only 2 times and then was high yield. They said this is one of the priority, the first reason that makes them to prefer this our new entry. The second one is early maturity, because that one matured earlier, much earlier than their own. As I said, up to the time we terminated this year's trial, the farmers' material did not produce a single pod. That is what they noticed, early maturity. And with the even early cessation of the rainfall that we experienced in Bakura and Minjibur, that's Axis, Kano and Zamfara state, the materials also perform wonderfully.
Okay, now finally, what do you have to say to Nigeria on this technology?
Well, this is a very good technology that is our research. Because as I said, many years has been spent in trying to identify the source of resistance to this insect. Many years has been spent without even identifying the source of resistance. With about 15 different, I don't know whether a common Nigerian has ever seen 10 different types of cowpea, only 10 different types of beans. But with this one, the International Institute of Tropical Agriculture, with other scientists internationally, they assemble, I said, 15 different types of cowpea, 15,000, assemble it. When they assemble it, they screen them and they couldn't find a single source of resistance. That's why they went into this biotechnology means or technology to come up with the lasting solution to this one. And the lasting solution is to go for the host resistance technology, that is to breed a variety that will have an inbuilt resistance that can confer resistance to this insect.
Sylvester Ofor, thank you very much for your email. You say you studied plant science and biotechnology at the University of Nigeria, Nsukka. You would like to further your studies in genetic engineering and want AGRIBIOTECH to advise you on how to go about it. Well, I have a response to your inquiries from the Open Forum on Agricultural Biotechnology. That was the Open Forum on Agricultural Biotechnology's response to the email from Sylvester. And Sylvester, I hope that response effectively answered your inquiries, as I sincerely wish you all the best in your academic pursuit in biotechnology. Keep the mails coming as we provide you the needed answers on questions on biotechnology and agriculture. Remember, the email address is agribiotech1@yahoo.com. You could alternatively tweet your questions at agribiotech13 or post them on our Facebook page, AgriBiotech on TVC. I am Lara Afolayo. It's bye for now.